Large foundation models, or LFMs, like ChatGPT, are trained with general-purpose datasets at scale, and they are then fine-tuned to align well with human intentions. This fine-tuning or alignment is usually through supervised learning, where humans are often involved in the training process. Big question now is, can we use another model to supervise an LFM, be it a ChatGPT model or an open source model, thereby eliminating humans altogether? Recent models like Alpaca, Wizard LM, and Vicuna seem to have explored this direction to produce smaller models compared to the teacher model, which in most cases is ChatGPT or GPT-4. What these models have is called instruction tuning. Let's get into the details of instruction tuning soon, but the drawback of instruction tuning is that the resulting models seem to lack reasoning skills that are pretty much the strength of teacher models like ChatGPT. Let's welcome Orca, the model that addresses this very problem, with performance at times as good as ChatGPT, or if not better. Whereas Vicuna was 13 billion parameters, lags behind ChatGPT, Orca, with the same 13 billion parameters, seems to do a far better job. So, what's the secret recipe here? That's prior to Orca. In instruction tuning, the structure of your prompt is a simple user instruction and an input. The output, of course, is a response from the LFM. You input different samples of these user instruction and input combinations to the teacher model like ChatGPT and generate outputs, thereby forming a small dataset which is then used to fine-tune a small resulting model. Existing methods for instruction tuning, such as Alpaca or Wizard LM, use this strategy of self-instruction. The first problem with this approach is that the queries generated through self-instruct are limited in diversity and complexity. They are quite simple, like what is the capital of France? Now, the second problem is that some methods rely too much on imitating the teacher model, thereby not actually learning to trace the reasoning process by the teacher model. Now this is big. The third problem is the evaluation protocol itself employed by Vicuna or Wizard LM, which use auto-evaluation using GPT-4 as the judge. However, GPT-4 seems to be biased in its evaluation and so overestimates the abilities of these smaller models. Let's see how Orca addresses these three problems. To address the first problem of instruction tuning, Orca explores explanation tuning. Now, in explanation tuning, system instructions are provided to guide the system to form a well-reasoned responses. These system instructions could be words like think step by step, to induce chain of thought reasoning, or it could be other words like explain like I'm 5, or being helpful or informative, etc. Beyond this, the system instruction can also specify the tone, task, format, and limitations to diversify the response. In this paper, they have used a total of 16 system messages such as you're an AI assistant, provide a detailed answer so user don't need to search outside to understand the answer. These were handcrafted in order to induce reasoning capability by using words like step by step. They also induced Orca to generate long and short answers by explicitly asking to generate explanations. Using system messages also established what is acceptable and non-acceptable behavior. To train the model, they construct a dataset derived from the FLAN v2 collection. The FLAN v2 is a collection of 5 sub-collections such as chain of thought, dialogue, and natural instructions, etc. Each sub-collection is associated with multiple academic datasets. Here is an example from the chain of thought collection, which in turn has 18 tasks involving math problem solving and common sense reasoning. The system message could be, "You are an AI assistant that helps people find information. The user will give you a question. Your task is to answer as faithfully as you can. While answering, think step by step and justify your answer. The problem is to pick which sentence is not logical." The ground truth answer from a human is that sentence A is not logical because flooding can cause damage. Here are the responses or explanations from both ChatGPT and GPT-4. ChatGPT concludes that sentence A is not logical as it suggests that people in deserts look forward to something harmful, and so sentence B is logical. GPT-4, on the other hand, concludes that the same, but comes up with a different explanation that sentence A suggests a destructive event, and so sentence B is more logical. This is just one data sample from the dataset being collated to train Orca. They employ the sampling algorithm to generate a set of n queries. The idea is to first sample a task T, and from that task sample a query Q and add that query to the set of queries to return, which is this uppercase Q. We do this without replacement so that the curated dataset does not have any duplicates. This algorithm, they generate 5 million instructions, both using ChatGPT and GPT-4 as teachers. As Orca is trained progressively, they first use ChatGPT as a teacher in the first stage and then move to GPT-4 as a teacher. As GPT-4 tends to generate longer explanations with better reasoning, ChatGPT acts as a stepping stone in addressing the capacity gap between Orca and these GPT models. Considering that the cost and response time taken by GPT-4 is almost 10 times compared to ChatGPT, they use all of the 5 million data that they have gathered with ChatGPT and only use 1 million with GPT-4. During training, they also use one more technique called packing, where they concatenate samples into a single sequence, limiting each sequence to 2048 tokens, thereby making the most out of the available hardware. Even with this setup, they use 20 NVIDIA 100 GPUs with 80 GB capacity each, and it seems to have taken 160 hours to train ChatGPT augmentations and another 40 hours for GPT-4 augmentations. And in each stage, they train for 4 epochs. Our focus for evaluation is that of reasoning, and so I will stick with 2 main datasets, namely AGI Eval and Big Bench Hard for evaluations. The AGI Eval is a fantastic benchmark for evaluating models for reasoning and problem solving. So it's derived from qualification exams like GRE, GMAT, and SAT. Orca is only evaluated against multiple choice questions, and so they have reported accuracies of the models for questions from these examples. The results indicate that the Orca model outperforms Vicuna by 42%. However, it lags behind GPT-4 by a significant margin. Of course, it's only a student model of GPT-4. This result is also interesting because it shows the significance of progressive learning by using ChatGPT as a stepping stone. By training on GPT-4 alone, ignoring the ChatGPT data, the results look worse, motivating the need for progressive learning using ChatGPT. The second benchmark, as the name implies, is a big bench hard. It's a suite of 23 challenging tasks which are notoriously beyond the capabilities of current language models. In this work, they have only chosen multiple choice questions for evaluation. For instance, the task could be a temporal sequence of actions, such as questions about what time certain events could have occurred. In this example, Tiffany went to the beach. Between what time could they have gone to the beach? The results of evaluation on Big Bench Hard reveal that Orca outperforms Vicuna in every single task. Though these results are mind-blowing, there are some limitations. As mentioned in the paper itself, these experiments were conducted in research settings, and so it's better to carry out additional analysis before using it in any other downstream applications. As the model is built on top of Llama, it does come with the standard set of limitations like bias, hallucinations, and lack of contextual understanding and transparency. The paper clearly concludes that learning from step-by-step explanations could significantly improve the quality of the model, irrespective of the size or the number of parameters in the model. I do agree with the argument of the paper, and I feel that there are billions of parameters staying unused in large language models. So let's hope for many more exciting small size models to come. Till then, please stay tuned and I'll see you in my next. Bye.